Hello and welcome to this video from P7 unit about planets and trying to see how naked eye astronomy, our observations of planets, has helped us to understand the solar system. So this video really is sort of planets and the solar system, and this is where we're going to bring together and finally get our view of the solar system, bringing together everything we've seen about the Earth, Sun, Moon, the stars, and finally the planets. And let's take a look at this picture. Here we are. We've got a picture of the night sky, and it's not a photograph. This is a computer-generated image. But what I did for this to find this picture, I did a Google search. I searched literally for most planets visible with the naked eye, and this is a picture from a few years ago of an event that did happen when the following planets, when Jupiter, Mars, Venus, Saturn and Mercury could all be seen with the naked eye from planet Earth. So as long as you had your clear cover, you could see these planets from Earth with the naked eye. These other stars would also have been visible, but these planets would have been visible. And the thing that amazes me is that astronomers would have been able to predict and know where they were and at what time and how high and how bright, possibly even. And they could have said to you, the best time to do this is exactly at 3 AM. You don't want to go out at 4 AM because by that time these ones have gone off over the horizon and these ones have gone here. But astronomers know this, and they know where they are and they know where they're going, and we know these patterns, and that's mental. So we're going to look at planets. What we're going to look at today, we're going to try and look at which are visible and when are they visible. How do we know that they're not just stars? So obviously they're just, look at this. They just look like pinpricks in the sky, don't they? How do we know they're not stars? We're also going to have a look, use this to think about what was the view of the solar system back in the day. And then we're going to think about how planets move and how do they appear to move as well. So yeah, a couple of aspects. How do they appear to move and what's actually happening? And we're going to try and see an explanation with this. And then what is our model of the solar system now? What do we think the solar system is like now, and how accurate can we be? So here is a picture of a night sky. There's the moon. Check it out. Hey moon. And there is a planet. And how do we know it's a planet? Two things, and you can do this yourself if you're looking at the night sky, even from London, even from Dagenham, you can see stars and you can see planets fairly frequently. And two telltale things. One, they do not twinkle. That's got to do with the fact that they're bright and big. So actually they're going to be bright, they're going to be bigger than other stars, and they do not twinkle. The reason they don't twinkle is because they're bright and big. A star is just a tiny little pinprick. It's a really, tiny little thing, a star, and because it interferes with the atmosphere, because our atmosphere is made up of particles and air, it does cause a little bit of twinkling on that, on the edges of it, and because it's got such a tiny area in the sky, it's got such a low angular size, it looks like it twinkles. But the moon doesn't twinkle, the sun doesn't twinkle, and nor do planets, because they're big enough not to worry about twinkling. But anyway, these are planets, and for hundreds of years we've known that these are planets, and we've been able to see that they're not the same as stars. We've been able to see that they're planets. Now, before I go into talking a bit more about how we know planets move and what goes on with them, I'm just going to talk a little bit about the universe and what people have thought about the universe for a long time. This is, here I just did a search in Google for sun god, and these are all images that come up. We've got Helios, the sun god, the Greek god. We've got the god of Ra. Where is he? Down here, the Egyptian sun god. We've also got Aztec, Mayan, Hindu. There's a lion in the middle there. I don't know why there's a lion, but these are all different. Oh look, there's Obama in the middle of a sun. But apart, ignore Obama, and we're looking at historical images of the sun and the faith that people had in the sun. And people, for a long time, ancient peoples, maybe some people even still today, thought that the sun was a god, and thought that the stars were the heavens, and thought that there were angels looking down on us, and had these superstitious beliefs. And who can blame them? What else would you think they were? They're beguiling and mysterious, and God only knows what was going on. But for a long time, people thought that that was the case. And even more recently, up to a few hundred years ago, people thought that the Earth was the centre of the universe. This is a medieval map of the universe with the Earth firmly at the centre. And here we've got Venus and Mars and Jupiter, the planets, going around us. And I can't remember where it is, somewhere on here, the sun as well is orbiting us. And people believed, and Christians believed, the Catholic Church believed, that we were the centre of the universe, and that the planets all circled us, and that the stars all circled us, and that God created us, and God created the heavens, and He put us right smack bang in the middle, because we were the most important things. And it was only through scientists studying this system that we were able to break away from this geocentric view with the Earth at the centre, and come towards this heliocentric view with the sun at the centre, and here's the Earth in different points of the year moving around, and here around the edges the constellations. These are things we've seen before. But it was through groundbreaking work of scientists who noticed this sort of thing. Galileo Galilei, a 15th, 16th century scientist who was put under house arrest by the Catholic Church. He was house arrest for his scientific work, and he was he was discredited, and he also had to come out in public and say, oh, actually I made it all up. I'll tell you what's discredited is my spelling. Discredited. And yeah, he was basically forced to renounce, that's a good word, renounce what he had found, because people didn't like the fact that the Earth isn't the centre of the universe. These are a series of photos taken over the course of, I think it's one photo per night at the exact same time. So this astronomer came out, say at midnight every single night, and he took a photo of the same section of sky. And here is Mars on the 1st of May, here is Mars on the 2nd of May, 3rd of May, 4th of May, 5th, 6th, 7th, 8th, all the way through the month. And Mars and the other planets do this as well, are what medieval and olden time astronomers called wandering stars. They called them wandering stars because over the course of time, when they mapped out the heavens and when they saw these same patterns repeating, they were really confused by this strange wandering behaviour. And they came to realise that these weren't normal stars, these were planets, and they were doing something strange. They were following a strange pattern, and this pattern, it wouldn't really work. I mean, why on earth would this happen? If we're at the centre of the universe, why is this planet or star or whatever it is, why is it jumping around us? Now, people were so desperate to hold on to the view that we're at the centre of the Earth that they came up with ideas like this. I say, well, the Earth's here in the middle. This is the Earth, and it's simply what's going on is that the planet is doing a loopy-the-loop fashion, and that's perfectly normal, perfectly natural for planets to have a loopy-loop sort of system. But of course, they couldn't back that up with forces of gravity or orbits or any science. That's just to try and fit the old geocentric model. This is another one, another thing that they came up with, well, potentially we've got this sort of yo-yo effect and we're orbiting in and out of here and there's cycles and it's spinning around and whatever, and people really were desperate to hold on to this old view, as often happens in science and in society. But what was happening was this wandering of the planets was taking place, and it caused people to reevaluate what was going on. And let's have a look. This can be explained by how we understand planets to move now. So we are going to draw ourselves a planet Earth, and planet Earth is going to be orbiting around, oh, look at that nice green Earth. Planet Earth is going to be orbiting around the Sun, and Mars is going to be orbiting around the Sun as well. So here we are with our two planets, Earth and Mars, and they're both going to be orbiting around the Sun in this direction. Okay? Now, this effect, I'm going to go through this and show how, as the Earth goes around the Sun and as Mars goes around the Sun, how their relative motions and relative behaviours can result in it appearing, Mars appearing to wander across the sky in a funny pattern. Now, this depends on us accepting the fact that these stars that are really far away, throughout the year, wherever we are, anywhere on our orbit, they look like they're in the same position. Look, over this course of the month here, this star exactly the same time every day, same place. Because they're so far away, their positions don't change, but stuff close by, or perhaps it might. So let's have a look. On the first night, we go outside with our eyes. I suppose we could use our eyes. We have a look, and Mars appears to be here. Fair enough. And let's go out the next night when the Earth has moved, when Mars has moved. This is weird, this thing. Why is it? Leave the shell behind. Alright, so where's Mars now? Here. Mars has moved in the sky. Alright. They both move by the same amount. I'm not bringing all of that with me. Just the planet, thank you. Okay, so we've moved the Earth and Mars again. Same thing from Earth. Mars moving across the sky. Okay, nothing unexpected so far. It's still moving. But now we get to an interesting point. Right, what we now start to see, because the Earth has less far to travel, is that Earth starts to overtake Mars. And so this regular pattern of its journey has been disrupted. Earth moves on, Mars moves on, but now from Earth it appears that Mars has gone back on itself. I'm just drawing it behind a little bit just so that we can still see where the X is, so I don't overlap my X's. Let's keep the Earth going. Just you, Earth. Yeah, there we go. Who's a good Earth? Yes, you are. Mars, well done. Come with me. Yes. Mars moves on. But from Earth, what do we see? And hopefully now you're getting the idea, as painstaking as I'm being with my drawing. You see Mars here, and still the inexorable march of our two planets as they go around the Sun. We then get to a point where Mars, in inverted commas, is catching up with Earth, and we see its motion there. Earth moves on, and now because we're going around the inside of this circle section here now, we end up with the Earth Moving on, Mars catching it up and appearing here. Now if I trace the pattern that Mars has taken across our sky over the course of these nights, it appears to have looped back on itself in the sky. Thus, this is retrograde motion. It's retrograde motion because it's returning, it's going back on itself. And this retrograde motion is a result of these concentric orbits. Concentric just means when you've got one circle inside another. So here we've got a system of a whole load of circles inside another, and at the very centre of our circles we've got the sun. Did you notice my sun looks a bit like an egg? But anyway, we've got the sun at the centre of these circles, then we've got the planets going out and out and out in these concentric rings, and because of these shapes and because they extend out like this, we get this result. And putting this all together, we get our solar system. Here we are, planet Earth, third from the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and here poor Pluto, downgraded recently, which I'm very sad about. But these are the planets, and we can track them, we can see them, and we can work out where they're going. And this is what the maths shows us. It shows us that we're spinning around the Sun, and so are they. And this is our solar system. Now there's other stuff in here as well. We've got some asteroids now and again, we've got meteors, space debris, ice, rock, bits of dust and gas, but this is it mostly. Way out beyond Pluto there's some other large lumps of rock, and we think there might be some other things around about the same sort of size as Pluto. Still looking for them, still looking out there, but they're very hard to see because they reflect so little of the sun's light when they're that far away. But this is us, this is our solar system, and we know all of this just from looking at what's around us with the naked eye. Yes, some of these details probably we've embellished and enhanced with the use of telescopes, but we know a hell of a lot just by looking out there.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
So, which planets are visible and when are they visible? These ones are visible: Jupiter, Mars, Saturn, Venus and Mercury, all visible with the naked eye. When are they visible? When they're near us. We're all orbiting the planets, we're all orbiting the Sun, but we're not in a line like this. We're all going on circles and at different speeds and at different rates. So if we imagine our Sun in the middle here, I always try and use that one, it never works. Let's imagine our Sun in the middle here, then going on these loops. So let's say that's for Mercury, this one's for Venus, that's Earth, and Mars even further out from there. You know, they could be all in different places. So we might have Mercury on this side and Venus over here completing its orbit, and maybe Earth is here, but Mars might be all the way around on this side. So we're not going to be able to see Mars at this time of year. We will be able to see Venus. We probably couldn't see Mercury, but who knows, Jupiter might be just here. So we'd have a good view of Venus, we'd definitely be able to see Jupiter. So it depends on where they are. At different times of the year they're going to be in different positions going round at different rates. What was the view of the solar system? Well, in the olden days we had a geocentric view. Geo, which means the earth, and centric means center, earth centered. And that was wrong. What is our model of the solar system now? Heliocentric. That is that the sun is at the center, and that is good so far as we know. Obviously it could You know, we might find something out in the future that makes us realise we've got this wrong, but I think we're pretty sure this is a good model. We're pretty sure this is good. It's evidence based, which the old one wasn't. The old one was based on, well, if you ask me, it's based on arrogance. It's God made us, God put us at the centre. It's just a leap of faith there. How do they move? In concentric rings. We've got concentric orbits. We're all circling the sun. Sometimes we overlap each other. How does that manifest itself? With this retrograde motion. Retrograde motion. It's very important terminology. Here we go. Retrograde motion. Copy that down if you need the spelling. Retrograde. And this is why, because we are overtaking, in inverted commas, Mars as we loop around it here. And that is planets, and that is our solar system, and that is astronomy with the naked eye. Guess what? We're going to try and look a bit further now. We're going to try and look deeper into space, and to do that we're going to need some telescopes. So let's move on to the next section. Let's grab ourselves some telescopes and find out what's going on in the universe. Excellent.